Welcome to ClickMyProject.com. Now we are going to discuss about the project Multi-Level Attention Network for Retinal Vessel Segmentation. Now we are going to discuss about the abstract of the process. Automatic vessel structure segmentation is an essential step towards an automatic disease diagnosis systems in the medical field. The task is challenging due to the various shapes and then the size of the vessels across the populations in the retinal regions. Segmentation of retinal blood vessels is an key step in the diagnosis of fundus diseases like the cataracts, glaucoma, diabetic retinopathy, and the main diseases that causes the blindness. In this process, we have implemented the segmentation that can be effectively and extract the features from the images by means of the patterns. However, the convolution and pooling operations also filtered out some useful informations, and then finally we have applying the classification methods to classify whether the input image is an normal or abnormal. Finally, the performance of the parameters will be evaluated by means of the accuracy, sensitivity, and specificity. By means of accuracy, we can justify our process is efficient or not. If the accuracy level is high, the efficiency of the classification will be high. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. This project consists the modules such as input image, pre-processing, segmentation, feature extraction, classification, finally performance estimations. These are the overall steps we done in this project. At first, the input image is taken from the dataset. The dataset here we are used is drive dataset for the retinal images. So after getting the input image from the dataset, we just move to the next stage of the project, that is the pre-processing. In this pre-processing, we have carried out the two steps. One is the image resize, then the another one is the image enhancement by means of the CLAHE method. So for image resizing, we are going to resize the image in the size of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After doing the resize, we have enhanced the pixels by means of the CLAHE method. After doing the pre-processing, the pre-processed image will be the input for the segmentation. In this segmentation step, we have three kinds of segmentation, that is the thresholding, patch extraction, and vessel segmentation. After doing these three techniques, the vessels regions will be extracted from the other retinal portions will be eliminated. After doing the segmentation, we just move to the next stage of the project, that is the feature extraction. So in this feature extraction, we are going to extract the two kinds of features, that is the pattern and then the texture oriented features. The pattern is extracted by means of the local binary pattern, that is the LBP, here represented as an LBP. After doing the pattern oriented features, we are going to extract the texture oriented features by means of the deep learning method MLA. After extracting these two features separately, we are combining these two features to generate the test feature. After generating the test feature, we are going to do the classification by means of the K nearest neighbor classifier. In this classification step, we are going to predict whether the input is normal or abnormal. If it is an abnormal, it will deduct whether it is an microaneurysms or else the exudates method. So these are the final outcome of the results during the classification. After doing the classification, we just move to the final stage of the project, that is the performance estimation. In this performance estimation, we are going to estimate the performance like accuracy, sensitivity, and specificity. By these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2015B and change the current directory. Then if you want to execute the process, just right click in the main_GUI.m and select the option run. Once you selected the option run, the user interface will be open like this. In this user interface, you can see the several push buttons in the right hand side for the controlling purpose, and then the several axes and tables in the left side for the display purpose. First of all, we have to click the button input image. After clicking the button input image, we have to select the image from the dataset. So in this dataset, we have both normal and abnormal fundus image. We have to select any one image from the dataset. The corresponding image will be shown in the axis 1 with the title of original image. After selecting the input image, we just move to the second stage of the project, that is the pre-processing. So in this pre-processing, we are going to do the image resize. So this is the resized image. You can see the difference between the input image and then the resized image. So the input image having the different dimension, the resized image having the peculiar dimension of 256 cross 256. After doing the pre-processing, we just move to the third stage of the project, that is the segmentation. So in this segmentation, only the vessel regions should be extracted and then the other regions should be eliminated. You can see the results like this. Yeah. After doing the segmentation, we just move to the feature extraction. So in this feature extraction, it will extract the two kinds of features. One is the pattern oriented features, then the another one is the texture oriented features. So the first of all, the pattern oriented features will be extracted by means of the local binary pattern. The image is represented here and then the corresponding values is represented here. So after extracting the features from the image, we just move to the classification step. In this classification step, during the classification, it will import the train features and then the train features values are shown in this table. After importing the trained features, we just do the classification whether it is a normal or abnormal. The results are shown here. After doing the classification, finally we have to evaluate the performance by means of the performance parameters, accuracy, sensitivity and specificity. You can see the values of accuracy, specificity and sensitivity in this table, and the corresponding graphs will be shown like this. Thanks for watching this video.